So Billy is recording what I'm doing and saying. So just before we start here, two important points. This one has to be cleaned before filling grease. It's very important that the cap is on and that you check that there's no dirt in it. And this cap should always stay on. So this is kind of the two places where we get most of the contamination into the pump from. It's by dirt in this one and dirt inside the filler. So if this is living like this and you're driving around, all the sand will gather inside. And when you refill it, we'll push it straight into the reservoir and end up in the pump section. And it'll turn into a grinding paste, basically. Oh. Very important. So we're going to connect the Groeneveld diagnostic tools. It's basically a adapter, a plug in between the machine harness and the pump. So then we have all this electrical wiring.
That's one question.
Yes.
But what if unexpectedly the thousand percent get into the temper, prison temper, by contamination, then what we can do?
If you know that you have put something in there, then you can take the pump apart and clean it. If you know that you have, yeah. So if you know that you've got something in there, you can disassemble the reservoir and you can clean it. So this can be taken apart from the pump, and internally in the pump, it's a bit more work, I think, but it's very easy to take the reservoir off. Let's see it. So just a couple of quick questions before we go on with the greaser. You recognize this one? Yeah, it's transmission filter. This is for the brake cooling. Brake cooling, yeah. Then we have this one. We have hydraulic level, and we have brake cooling level. So we didn't get time to show this yesterday, but we can do it just now. If you notice on the hydraulic tank, you have two drain ports. You know why?
To the drain.
You have two drain ports. Why do we have two drain ports on a hydraulic tank? It has something to do with our emergency steering pump. As I mentioned, we have a separate pump on the transmission. So that's kind of a backup in case the main hydraulic pump is failing. So also in the hydraulic tank, there is a in the tank, there's a divider. So about maybe this high. And if you have a failure on the main pump, like a big leak, kind of if this hose falls off, all that oil will disappear. But you still have a small reservoir only feeding the emergency steering pump. You have kind of a, it will be a kind of a backup. That's why we have two chambers. So.
메인 펌프에 있는 똑같은 저기 빠지들어지면서 예, 백업을 스티어링 스티어링 기획이 나오고 그래가지고 격벽으로 왼쪽이 왼쪽이 뭐였어? 응. 왼쪽이 이렇게 있으면 오른쪽이 그 메인.
Yeah, so if we have a catastrophic leak, we still have some oil for the steering left. So we can look at this one. So turn our attention to the screen, I think.
AGS? 왜 AGS는 쓰기 싫은 거야? 왜? 혹시 가다
Maybe close this door a little bit.
그렇긴 한데 근데 얘도 뭔가가 더 있겠지. 그러니까 뭐가 있는 거 대체로 뭐 있어 오픈가? 세 개밖에 없던데.
So to use the diagnostic tool, we have to have a software. Then there's something called PCGNA. And that's the Groeneveld diagnostic tool. So we use one that's called Twin 3 because that's the type of pump we have. It's a Twin 3 pump. We also have a program called Twin 2, but that's kind of for older Moxie trucks. But we use the Twin 3. Did you leave the ignition on? The ignition is on? Or did you turn it off? Key on?
Yeah.
Or is it off? Yep. Yeah, this is kind of a start window. Up here you can select which communication port you use. For some reason, sometimes you have to switch them. If you have several options appearing, then you have to try which one is working on your laptop. So let's see if it's working. It's not the quickest program to connect, so it takes a little time. You can see now it's powered up and it's actually talking to the pump. So this is our initial window. I'm just going to close this one. So here we have our kind of basic information about the pump. This is information about the user who last accessed the pump and last did any changes on the pump. Because all these softwares have their own separate user ID because they have to use it with a license. And that license gives as a number on it. So every time you access the pump or do a change, that number is stored in the pump. Yeah, it can synchronize the internal clock. You'll have information about the pump serial number and machine ID. Yeah, so this is automatically detected. This is set up at the factory because we actually pair the pump to the machine. So we actually access the pump and we type in the machine number and so on. So whenever we have a pump that's returned for some reason, we can see which machine it was installed on. So it makes the traceability of the part much easier. Yeah. Then we get into parameters. So this is the setup of the pump. This is the control function of the pump. As I mentioned yesterday, if you buy a pump from us, this will already be pre-programmed. But if you buy directly from a Groeneveld dealer or someone else, this can be anything basically. So the timer interval we use on our machine is a lubrication cycle every 30 minutes. That's the requirement. And that has to be 30 minutes anyways. You can shorten the time if you want to, but you cannot extend the time. So 30 minutes is the minimum. Oh, sorry, maximum time between lubrication intervals. So if you have a customer in really hard conditions, you can shorten it to 20 minutes or 15 minutes if you want to. That kind of 30 is maximum. We have a duty mode selector. We don't use this one. This is more if you have it on an excavator, you can have this separate handheld control. Then you can select between separate modes depending on what work you're doing. But on ADT, we use just one fixed duty mode. So we select 30 minutes on heavy duty and select heavy as the use parameter. Then you have this one, maximum pump time. So when the pump is trying to build pressure, it's going to try for 6 minutes. It's going to be pumping for 6 minutes to try to build pressure. If it doesn't build any pressure, it will stop and it will switch to the B line. And it will do this 10 times, back and forth, just to try and get the pressure. So it will actually try for 60 minutes before it gives you a fault code if it can't build pressure. Yeah, this is not so important. This is just some internal. We set the current limit. We set the temperature limitations. This one is usually just 0. It's for something that we don't use. Up here we set the activation of the pump. So we use ignition pin. We select low level pump stop. So that means when you get the low level, the pump will stop. That's to avoid sucking air into the system. And we select 10 cycles with low level. So the pump, when the reservoir is getting low, that kind of follower plate will come down and trigger the low level switch. Then you have 10 cycles, so about 6 hours of driving before you get a speed limitation at low level. Yeah, this stuff is for other pumps, so it's not used in our application, but these two are very important to be correct. Let's see. This one also has to be activated. That means that we control the pump via CAN bus. So that means that the start of a lubrication cycle is controlled by CAN bus. So when the machine is in idling, in neutral, the pump is kind of on pause mode. When you put the machine into gear, it will start a cycle. So it's only greasing as it's driving. And this is to avoid unnecessary greasing. So we kind of save a bit of money by not greasing when the machine is at standstill. When all this is done, you can click Send to Twin, and that sends your setup to the pump. You can also save this setup for later use, and you can also load a previously saved setup. Then you have a diagnostic part in here. So on this side here, you can see all active fault codes inside the pump. The same thing will also be displayed in the truck gauge panel. You also have some fault code counters down here. So if there's been no pressure change, there's no pressure or constant pressure, you'll see that here. Yeah, overcurrent, low supply voltage, or how many low level stops it's had. In the center here you can see a bit what the pump is doing at the moment. So right now it's in pause mode because the truck is turned off. You can see the remaining time of the timer. So I'm guessing when we put it into gear now, it'll either be on interval waiting for next cycle or just about to start a new cycle. Here you see how long time it has remaining. This is the time it used to build pressure on the last cycle. And yeah, it's actually remaining time until next cycle is 5 minutes there. So when I put the machine into gear now and start driving, in 5 minutes, it'll start a lubrication cycle. You can see your pump motor current. So it's easy to detect if the pump is running very hard or if it's not building pressure. You can see it's running very light sometimes. Yeah, supply voltage, internal temperatures, and there's a small battery for memory functions inside, so you can see the state of that. And a couple of more counters. Up here we can do some direct controls of the pump. So you can switch it from automatic to doing single tests, that it will run one cycle. You can do multiple tests, so just keep running continuously. And this one is kind of it'll skip some of the parts in this cycle in the process, just to make it go even quicker when running the test cycle. Because a normal lubrication cycle, you have the pump pressure buildup, then it reaches pressure, then it will hold that pressure, depending on how long it used to reach it. And then it has a ventilation time, where it kind of depressurizes, and then it goes to wait the next cycle. So with this one, you kind of shorten down all that waiting periods in between. So it just builds pressure, drops it, switches to the next line. So it kind of goes quicker, the fast cycle testing. So that makes it a bit quicker. If you have a system that uses long time, for instance, to reach pressure, you don't have to have that waiting time in addition to it. If you select manual, we can run the pump separately. We can activate the valve that switches between the two circuits, the two supply lines. We can see if we have inputs from the truck, if the timer is running, if the pump has been disabled. And we can see inputs from our switches in the system, and that's basically the test switch and the pressure switch. We can do some simple tests. This one and this one you can do also on the pump itself or via CAN PC.
PCJ. Although technicians that brings up these tools, I have tools.
Yeah. There, you should have this tool if you're troubleshooting the auto greaser. The CAN PC has a very limited function for the auto greaser. We can do the two testing activations. Oh. We can we can activate that, and we can actually reset the pump if it's been lockout due to a fault code. But we can't do any of this in CAN PC. So we have a very limited function towards the pump in CAN PC. Yeah. So. Yes.
Is there any logic to check the PCB temperature to run up the brew?
Oh yeah, there's a sensor inside the PCB. Yeah.
If the temperature is too high,
then the pump will stop. Yeah. So it's kind of to protect, I think, the pump motor and also the PCB itself not having a power load going through it if it's very high. Yep. But 70 degrees is very high, so I don't think we'll see that temperature in the PCB unless the machine is on fire, I think. So, let's see. I can start a single test here now. Basically the same as I do if I use the pump itself. Then you can see actually what the pump is doing here during the cycle. So now it has actually activated the pump. So now it's maybe you can hear it. Here it's kind of churning. So you can see that it's pumping. It's running fairly lightly at the moment. You'll see as it starts to build pressure, you'll see this kind of start to increase. No, unfortunately not. The Groeneveld tool is a very basic tool, so they don't have that function, unfortunately. Problem? We usually go by pressure. Do you have pressure? Yes, no.
Like this, and this. So the main phase time is the maybe so now is the counting.
Yeah.
How to know this time the phase time is test one.
Yeah. So this can be a bit variable depending on the application. So let's say in hot conditions, you use very short time to build pressure. In cold condition, where the grease is thicker, you might use longer time to build pressure. It's not kind of a fixed setting for everything. Yeah.
The connected diagnosis tools.
Yeah.
Right, and just getting data.
Yeah.
So thinking how to know what is the problem, how to improve, how to fix.
Yeah. So first of all, you have your fault codes.
Just that one.
Fault codes is a very good indication. So let's say you have no pressure in line A. Yeah? Yeah?
It's maximum and minimum range
For
for any variable values.
no, we don't have anything like that, except for the current, which is kind of 10 amps. But this is kind of variable counter, so I don't want to use them as a guide. But here now, you can use this tool. Let's say, for instance, you have no pressure in line A. You can use this tool. You can activate the pump, and you can switch the valve to line B. So let's test if the switch is working. Okay, I can trigger the switch. Okay, there must be something leaking maybe inside the line. To know that it's electrically sound. So you can run kind of manual tests on each circuit by using this one. So I can start the pump, and by activating this one, I can switch between A or B. You see now it's on pressure, so now it's kind of pump is stopped, and now it's just holding pressure, just to make sure that all the metering units do their thing. Thank you.
Indication indication에 안 들었잖아. 그러니까 그렇게 제품 들었잖아. 그래서 뉴스가 이거 맞췄다. 그러니까 그치.
So for instance, this one now, as I mentioned, this is variable. This one now was depending on the pump time. So now it's pressure release, but that hold time is depending on pump time. So there's no kind of template on what that should be, because that can be different from grease type to grease type, ambient temperature, but so for instance, if you have a low pressure now constantly, and I start the pump, and I can look at the current, and it's running very light, maybe 0.2, 0.3 amps, then I know that the motor is running lightly. It's not building any pressure that's creating resistance. Okay, is there internal leak? Is the pump just not building pressure? Is it not grease coming to the pump? And I know that there's at least definitely no pressure in the system. So what we can do here now, we can try to so now we're just forcing the pump basically. You can see what happens when it starts to build pressure.
A비가 있었잖아요. 이게 싱글텔 비더블은 A만 치는 게 그냥 끝나서 월테를 가면 A도 하고 B도 있어요. 근데 지금은 이게 거의 매뉴얼로 그냥 때려서 그냥 박스 주는 것도 되게 아까는 시간이 걸리잖아요. 그래서
I wasn't sure how high the amperage can be when it's starting to build pressure. So now we're just running it constantly.
그다음에 이제 딱 어느 정도 빌드업이 되고 난 다음에 저기 이제 온 프레셔라고 되겠지. 위에 맨
Now we're starting to get resistance. Now we're up to 1 amp.
샌딩이 계속 노력 보여준 거야.
I'm guessing we should see the switch trigger fairly soon. Take some time. It's a very long line all the way to the back, so. So then we're on pressure. So actually now you can see the pump kind of starting to work a little bit. The amps are going a bit higher, higher, higher. And I can basically run this system up to 250 bar now just by doing this. But now you see that if you're on pressure, I'm just going to stop the pump now so you're not running it unnecessarily. But you see that when you're on pressure, you're about 1 amp, maybe a bit higher. If the pump is running and you see just 0.2, 0.3, no real resistance, that means the pump is not building any pressure. So you should see an amperage increase when it's building pressure. You also have that valve inside here, which kind of switches between the two circuits. It has two functions. I wasn't doing that.
안 바뀌는. 아까 전에 매뉴얼에 따라서 때리는 거 있었어. 그거는 바뀌는 게.
So the valve inside here has a function where it changes between A and B feed line. It also drains the pressurized feed line when the cycle is over. So let's say you're running, it's hard to draw, but if you're running cycle line A, you pressurize, it keeps the pressure. Then the valve will switch to drain that pressure again. At the same time, when you start the next time, it switch so you're going B line. And reach the pressure in B line, it'll switch to drain the B line again. This kind of makes sure that the system is pressureless between lubrication cycles. If this valve sticks, you can see that you don't get pressure because it's stuck on, or you get pressure only on one line. Then it can be sticking. Also, if you get a fault code that says unexpected pressure, you'll have, where is it? Pressure before cycle. That means that the valve has probably not shifted. So when the pump is starting the cycle, it's still pressure in the line. Then it can be sticking, so it hasn't released the pressure. Can also be the pressure switch. So you need to kind of check both of them. If you want to check the valve, you can do that from here. It's just by activating valve coil 1.
Oh, yeah.
Yeah. So I can hear it clicking. So it can mean that the valve is
있는데 A 안에 될 수가 있는 거야. A랑 B랑. 그래서 이제 페이딩 타임이 끝나고 난 다음에는 D 타임으로 다음 사이클로 넘어갈 때 그때 얘가 딱 해가지고 나머지 A 라인이 다시 그레인 하고 그다음 B 라인은 프레셔 라이딩 그다음 B 라인으로 끝나는 그레인 어제 한거 이게 세팅이 어떻게 되는 거야? 바로 세팅이 안 나왔다. 수요일이잖아. 일요일이니까 수요일이잖아. 싸우는 거 되게 된다.
so.
이게 만사연이 안 됐어. 그러면은 여기 뭐 보란이 안 되면 그 압력을 뺄 수가 없어. 그렇게 그렇죠. 압력을 뺄 수가 없으니까 저기 압력 스위치가 문제가 있거든. 이걸 들리면 보란이 많아서 안 되니까. 적절한 수준에서.
And the easiest way to check pump performance if you suspect a pressure issue is just to connect dial gauges to the pump output and see if you get pump pressure.
수가 있는데 빼고 다이얼 게이지를 박아서 봤더니 보란으로
Oh, it's not dial gauge, but pressure gauge. Sorry, pressure gauge. Dial gauge is something different. Yeah.
하이다 그룹 하이다 그룹. 네. 하이다 그룹.
Yeah.
그리고 받아서 정말 한 번밖에 못 써서 그렇지.
So the pump should be able to reach 250 bar
250.
by itself. If you connect, let's say at the back of the lubrication system, if you connect to the rear block, it has two spare ports, you should see 100 bar before the pump stops, because that's the switch setting, the pressure switch setting.
여기서는 250바 정도 나와야 되는데 끝단에서 한 100바 정도 나와. 250바에서 여기 뭐 멀잖아. 그러니까 끝단에서 한 100바. 여기서 딱 연결했는데 만약에 100바밖에 안 나면 펌프가 힘이 교체해야 돼.
그 샤프트 있거든요. 샤프트 계속 빼나가고 있대.
While I have it here, another thing that can cause problems with the pump is if you overfill it. There is a vent plug on the top here, comes out. If you overfill it, you can get grease into that vent plug. And as you start consuming, the vacuum will kind of keep that follower plate up there. It's very important not to overfill it, because you can potentially block the venting.
위에 에어 벤트 플러그가 있어요. 에어브리더가. 근데 하프로톤이 에어브리더가 막 써가지고 만드는 이제 그 그레이스 레벨이 떨어지고 나면은 거기에 이제 에어가 될 수가 없어요. 그런 식으로 문제가 있어요.
Yeah. So back to this one, we have some counters. So this tells a little bit about how the pump has been running. Yeah, runtime, ignition time on, cycles, pumping hours, how long it's actually been pumping, just kind of runtime diagnostics for a pump. Here you can see some error counters. So number of faults since it was installed. Number of faults since last time it was actually working correctly. And how many number of faults you had in succession, kind of maximum. And that's for all the faults on the pump. And yeah, you can see if you exceeded high level, low level numbers, the pump's been disabled. Here you can see the history of the pump. Select all. You can also select what faults you want to look at. So this pump doesn't have any faults on it. But if there were, it'll give you a time and date for the faults. I'm going to show you each individual fault. But this pump is working, so there's nothing here. Yeah. Yeah.
How to register the patch number and yeah.
The part number, yeah, that's fine.
Main.
Yeah, then you go to main.
The
Yeah, and it's basically just typing and click save. Yeah. It's this is not critical for aftermarket, I think. It's mostly for new machines and machines in warranty. When we get parts back, we can kind of keep them traceable. If you don't do this when replacing in the field, it's no big issue. But if you do it, it's a good thing, but it's not critical. Yeah, this is a bit the same as the other one, but it kind of shows everything the pump has been doing. So it kind of records everything it's doing in itself. So here you can see every time it started the pump cycle, every time it had completed one, pump time, every time the valve is changed over. This is kind of the Groeneveld full details. I think I should have selected none of them. So
그렇게 이렇게 로그처럼 나오지.
So this is basically everything the pump's done since day one. So this is today. We turned the power on, we turned the power off, on, off a couple of times. This is probably when I unplugged it and connected my test kit because it lost communication, it said. And now it had last communication with my user ID. So this is me. Started test cycles, I started manual ones. Yeah. Turned the valve on and off a couple of times. It's basically everything. Then you have a function up here that's called reports. And that creates a PDF about everything inside the pump. So it tells me the parameters, the counters. Yeah, it's not too much going on this one now, but all fault information will be in this file then. So. Yeah. Yeah. So this is this is pumps that I've been connected to. So they're kind of stored inside my laptop. Yeah. Yeah, it stores itself every time I connect. So I can go to file here now, I can store it or print it. So this is in your program. No. I don't think so. I never tried it. Yeah, you can change. You can put on some more information. You can't change the report itself. Yeah.
Can you save the event history to PDF file?
Yeah. So if I go to reports there now, go back on this one. I go to file. And I can,
This is just event history.
yeah, but yeah. So event history is here. Or you, I'm just showing you, but it's not very useful because we have also recording of all the fault codes in CanPC. But I'm just showing it to you so you know that it's possible to see very much details from the pump itself.
카피에서 그냥 다른데 이거랑 표 게임 리포트 이벤트 히스토리가 리포트가 되는 게 아닌 것이.
This one can't be stored because this is that will be a extremely long file. So this machine has about 10-12 hours on it now. You can copy and paste because imagine at 8,000 hours how long this list is going to be. So this is just for 10 hours. Probably not. I'm guessing they have a big recording because it's just a simple text file. So I think they can keep most of it.
많은 시간 되면 한 10분 걸려가지고 이렇게 되는 거예요.
You have to buy a box of papers and then put it into printer and start printing. Yes, I have your report on the.
진짜 이벤트 히스토리 엄청나게 많은 게 있어. 10시간밖에 안 된 장비가 다 있어. 다 촬영돼 있다던데. 한 1000시간, 10,000시간 이렇게 되면 척에 안 없어지고
프린팅하다가
막 끝까지 있는 거야.
깜빡하면 좀 프린팅하다 이거 막 되면
그러니까 하지 마.
So you can do automatic fast testing. Yeah. If it's working. So these two are useful if you're running bleeding of the system. If you have the repair of line, you can also use by holding this button for 7 seconds. Then also goes to kind of continuous multiple testing. Just going A, B, A, B, A, B. So if you're bleeding or repair the line, once you bleed the air out of the line, that's a good way to do it.
네. A, B 요가 왔다 갔다 해야 피딩 한 다음에 다시 들어있는 거죠. 그러니까 그런 것들을 할 때 그냥 이렇게 정도 쓰면 A, B 왔다 갔다 하면서 그 동작을 하는 거니까 만약에 후드가 이렇게 돼 있잖아. 나와야 되는데 안 나온다거나 앞에 에어가 차 있다거나 그럼 에어를 밀어내고 그런 것들을 할 때 그냥 필터를 넣고 실수 장비가 그렇게 하면 된다. 필터를 테스트 버튼 저걸 테스트 동안 쭉 해서 그러면은 저게 멀티 테스트가 있어요. 멀티 사이클 테스트. 근데 한 번 또 누르면은 좀 싱글
이거는 사야 되겠네요.
진짜 싱글 테스트인데 아까 전에 하나밖에 안 한다는데 이거 왔다 갔다를 안 하고 하나밖에 안 하고 근데 좀 눌러야 멀티 테스트가 되고
Yeah, just go pressure off, pressure off, pressure off, pressure off, pressure off.
그것도 테스트할 때 호스에 호스가 돼 있었는데 이렇게 나오는지도 확인할 수 있고 빠지는지도 확인할 수 있고 밀어내는 다시 그린이 돼 있어. 진단할 수 있지. 왜냐면 폴드가 뜨잖아. 다 떠져 있는 거 다 써. 그 캠피시에도 다 뜨던데.
So if you want that multiple tests to go quicker, then you just click on this one, past multiple test, and you click send to twin. So I'm not going to do it here, but what it will do then is kind of, because you have pumping pressure buildup, holding, and reduction. Then it will just be pressure buildup, reduction, pressure buildup, reduction. So it's much quicker. So that's especially if you're bleeding to the lubrication points. Because you won't have to wait then. So then it goes much quicker.
Holding period, all of the grease from the pump to the all of the
Yeah,
each section.
yeah. So
Operating.
that holding period is just during normal operation, just to make sure that all the measuring points kind of expel the grease to the different lubrication points. So in case you have a valve that's a bit slower than the other ones, it kind of gives it a bit time to do the lubrication to the different point. But if you're doing kind of repair work and you're just bleeding the system, you don't want to have to wait for this every time because it takes a long time if you're using the program. But
At that time, pump is working continuously.
Yeah.
At the holding cycle.
no, at the holding cycle, the pump is stopped.
Okay.
So
we can supply grease all of the ports, right?
Yeah,
Ah,
yeah.
okay.
So basically what it does that when it reaches pressure, it stops the pump, but the pressure will be kept from the pump since it's until the valve changes.
Okay.
Yeah, because the pump, you have a non-return on the pump itself. So all the pressure the pump gives to the system stays there until you switch the valve. Then you drain the pressure again.
이게 홀딩이 되게 백바라고. 이 백바로 계속 밀어주는 거. 계속 미는 거야. 저희 각보관에 디스트리뷰터 분배기에서 이렇게 봐. 그러다가 이제 사이클이 변할 때, 5분의 2, 밸브가 아까 전에 딱 소리 나는 거 있지. 딱 소리 나면서 기존에 있던 A라인에 있던 애들이 회수해. 또 빨아들여. 근데 그와 동시에 이제 B가 시작된, B 사이클이 시작된. B 사이클이 시작되고 또 나빠.
So this is how it looks. So this is the cycling of the grease pump. It will start pumping. The pressure will start to increase. Then you trigger the switch. Then the pump will stop. And depending on how long it used to build pressure, it will keep it at high pressure. The pump will be stopped, but it'll keep the pressure high. And when the timer is done, it'll activate the valve, switch it over, and drain the pressure to 0. Then you have 30 minutes. Same thing happened, but this time the valve is kind of activated because you're greasing the other line. Pump is running, pressure up. It's the switch, holding, and then deactivating the valve, draining the pressure. So that's basically how it operates.
이거 딱 있잖아. 백과 남자는 딱 끝나고 이렇게 되죠. 프레시어 리메이닝 베이스가 되는 거죠. 딱 붙었지만 오케이 하고 싶어.
Yeah. I think it's a good time for a coffee break.
Okay.
Yes.
All parts for the releasing
Yeah.
is very important, but which parts is most important in the racing and lubrication parts? Tandem bearing or
Yeah, for the tandem bearings. Yeah. Yeah, that's kind of the key thing we have the greaser for. Because they require constant greasing. Let's say for a hydraulic cylinder or something, if you skip greasing for a day, probably no issue. But if you skip greasing on a tandem for a day, you'll have damage. So that's why we have that 30-minute interval, and we also have very large metering units for the tandem. So they have 4 cc units, yeah, and 2 of them on each metering unit. So they get a high volume of grease. So it's actually a very important part of that daily check the driver does. Since we don't have any monitoring of the pressure to each point,
yeah.
you kind of have to walk around the machine and just see that, okay, I got grease. Yeah.
Just visually.
Yeah.
Can check that.
Yeah, especially for the tandem. So it's just by walking around here and see that, okay, I have grease coming out of the tandem. And just to see, you can also see all the other places when you walk around, but just seeing that, okay, I have grease coming out, I have grease coming out. Okay, it's constantly getting fresh grease. So basically everything except from the rotating shafts and the door hinges have greasy.
Questions. And we at around 11:30 because we need to put the tire in and
Oh, yeah.
the vehicle back. So
I have to put it back over there?
Yep.
Oh, really?
I think it's possible.
I was wondering if it was possible to drive on outside, because I think we're scratching the machine a bit going through the trees there.
I don't think there is.
I think we might sink if we do it today. Because I think it's just a flat area on the side of the road, but today we might sink in.
Go on the road.
No, if we go on the side of the road.
Might sink.
Yeah, maybe. Also, the road is very bad today.
Yeah.
We'll make the machine very, very messy,
Yeah.
probably. Yeah. So, couple of things doing your daily check on the machine. Look if it's just coming, especially on the tandem bearings. Yeah. That's kind of the key point that we have the greaser. So if you have an excavator, if you don't grease it for a day, no big issue. If you don't grease the tandem bearings for a day, you will have issue.
Okay.
So
I have a question about that.
yeah.
If the press pressure is even lower, army like failed, and then will the continue to pump?
Oh yeah, if the line failure.
Yeah.
Yeah. Let's say if let's see here. If this line fails, we have no monitoring.
Oh.
Yeah, we only monitor the supply. Yeah. So this is monitored. This is not monitored. The ones that goes to this one.
How about switch then?
It's on the back here. It's on the back side there. It's a bit hard to see, but and that sensor is watching these two.
센싱 하잖아. 압력으로 센싱하는 거.
이거는 압력으로
센싱하고 얘네가 끊어졌지 않고
이거는 센싱.
텐덤 베어링이 센싱 안 되고 그냥
계속 컨티뉴.
맞아.
바뀌었다고 하지 않았어, 한번?
So you have to kind of
메인터널때 이게 끊기면 어차피 안 되고 빠지니까는 문제가 있겠지. 내려오잖아.
근데 계속
내려오잖아.
나오는데.
거기도 마찬가지잖아. 근데 이제 똥이잖아.
왜냐면 잘리면 오히려
And there's a lubrication oil in the tandem bearing, right? So it
is for the pump. And I also added a troubleshooting guide for internal leaks in the pump, how to diagnose.
Show the troubleshooting.
Yeah. So this is for if you have pressure issues. So if you have air in the system, it basically look like this. And it gives you kind of this yes/no guide. So no pressure is the pump running heavily. Could be the 5-2 two-way valve stack that kind of changes between A and B. Shows you how to do testing with pressure gauges.
Good.
You also have how to troubleshoot internal leaking, as we mentioned yesterday. Here you can find if you have, if that O-ring, for instance, is damaged on one metering unit, then it will start to leak between the two cycles. If you disconnect now one line and you start the pump, normally you see a little bit of grease coming back. It's just a little bit and it should stop. But if it starts to flow continuously, then you know that you have an internal leak. And then you have to check the O-rings first. And if all the O-rings are okay, then it might be the block itself that's damaged. But that doesn't happen very often, but potentially it can happen. So,
Thank you.
yeah. We have the driveline left. I think we can do it while we're here, actually, because then we can look at the machine at the same time. So just short. I'm just going to get my clicker. So, yeah, D30, D45. The driveline is, this is just going to focus on the tandem bearings for the most and our planetaries and the tandems. The driveline is in essence identical, but it's just different size between them. So for the front axle, we have the limited slip differential, bolted to the transmission. Same as we always used. So that's a separate unit on the transmission that we have used now since basically forever almost. Yeah, with set of limited slip. Then we have our front hubs. They also contain the wet disc brakes. Then we have our rear axle or our tandems. It also has a limited slip differential. Then we have on the tandem housings, we have planetaries, similar to the front. The only difference is between the front and the rear axle. So on the front axle, on the tandem, we have brakes. On the rear, it's just a pure planetary. So we have 4 planetaries with brakes on the machine. But you have 6-wheel braking. Yeah, because they're connected through the gears of the tandem. So we only have 2 sets of brakes, but they brake all the 4 rear wheels. Because you have the planetary, so they're constantly connected. Sorry, the gears inside the tandem between the planetaries. And also, the planetary with the brakes on also has connections to the cooling. And this is similar for both models. You have just bigger components on the DF45. Yeah, front frame, rear frame. I guess you've seen that we have a bit special design on our rear frame. It's kind of sloping down compared to, for instance, a Volvo where it's kind of flat. This is kind of a part of the design concept of the DA. So we have a sloping lower rear frame. That means that we bring the weight of the payload and the machine towards the center and also down. So we have a lower center of gravity on the machine. And this combined with our unique turning hinge. Yeah, this is unique to us because we have the turning point, then the articulation bearing in front of it, which makes the stability of the front frame much better. If you go to a Volvo now, for instance, it's opposite. Then you have the turning and articulation behind. And this makes a big difference in the stability of the machine. So with our design, when you turn the machine, you have always 50-50 weight distribution between the 2 sides of the machine. So it kind of carries the weight in the direction the machine is turning. So you have same weight on both wheels, which gives good traction. Also very good stability. If you compare it to a Volvo, if you put a Volvo truck in full turn, all the weight wants to travel forward, meaning that a Volvo in a full turn has most of the weight on one wheel. So it's more sensitive to instability, so it's easier to tip over. You see, especially if you do take a Volvo and you place it in a full turn and you lift the body. You see the Volvo truck will go like this on the front frame. But our truck is maybe just like
안정성이 좋대야 이렇게 분배가 잘 돼가지고 단점이 있을 거예요. 그렇다고
장면 단점만 얘기하면 볼보로 별로는 나머지 먹으려고.
뭐 그렇게 지금 얘기하는
so. We have a very stable and very safe place for the operator to be.
You wanted to private.
Yeah, human priority. And also traction is very good. You know, Volvos, when they get stuck, they started doing like this, kind of turning back and forward. That's because they're kind of utilizing that all the weight on one wheel just to crab walk.
Ah.
Yeah. We have better weight distribution, so we don't really need to do that as much. Because we have same weight on both wheels, so we have better wheel grip, better traction on the front axle. We also have the tandem, which distributes the weight equally between both tires, so it gives us very good traction. We also have very good sideways stability at the same time. A little less comfort compared to a Volvo, since we don't have the same kind of suspension, but we have much greater stability. So the machine can handle some extreme angles actually before it falls over. So it's a very safe machine in that way.
좀 변형력이 적동을 해서 왜 이제 자동이 안 해? 그냥 아니 편집했는데 그냥 이런 얘기만 하는 거니까. 그냥
그 영상 하나 보시면 되게 코너링 이렇게 하잖아요.
네.
그러니까는 이건 이렇게 코너링을 이렇게 하는데 볼복 거는 어떻게 되냐면 이렇게 못 돌아요. 볼복 거는 무게 싣고 가면 이게 스티어링이나 이런 게 좋아서 우리 거는 이렇게 안정도 이런 게 있어서 그대로 따라가. 얘네 거는 이렇게 해가지고 벗어나 이렇게. 그냥 그 얘기하고 있지.
And also better service guys.
그렇대.
계속 그 얘기하고 있어.
So
Oh
just
my God.
just do like this. It's an old animation. So that's the articulation bearing. So this kind of position we're having gives the machine very good stability and traction when doing tight turns. It's a bit of sales presentation almost, but it's kind of, I guess it's interesting for you guys to know about why we have it like this. Yeah, as I mentioned, that rear frame design we have. So the center of gravity becomes lower on the machine. And we also have the articulation of the bogies, of the tandems. Yeah, so this is kind of the principal driveline of the machine. You have the engine at the front. Then we have the axles that we were looking on the day before, the lubrication points. So you have axle between engine and transmission. And you have axles between the front differential to the planetaries. You have the one going through the cardan through the hinge. Then we have a fixed axle on hanger bearings. This holds the parking brake. Then you have the last cardan shaft here. So all of these are needs to be manually lubricated, except for this one. But you have to manually lubricate this axle, this one, and that one. No. No, it's not too difficult. So when you're doing an engine service, you open the drain plug.
음.
You have to wait for the oil to drain. What should you do while you're waiting? Yeah.
되지.
오백션.
여기 500시간에 하나
So the interval is 500 hours. So
The interval is same.
500 hours.
500 hours.
Yeah. So while you're doing your other service, you can do this in between. And it's a very cheap investment to the lifetime of the driveline.
But a lot of customers confused and forgot the grazing interval.
Yeah,
And so also the
yeah, but
adjust is the too difficult.
그거는 지금 아까 전에 보니까
not really.
되게 중요해.
It's a little difficult, but it's not too difficult. The cabin takes 3 minutes to open.
Often.
Yeah. Then it's
And
just,
then grazing.
and you're done.
Mm.
At the same time, when you have opened the cabin, you can see, okay, everything looks fine here, no leaking. Underneath here,
Mm.
you have access to the differential side of the axle.
Mhm.
You have fairly good access to the one on the hub. So you just have to go underneath the truck.
Mhm.
Then you do this one, fairly good access.
어디다 탭을 열어놓고 해봤으니까.
And the other one is fairly good access. So all of this can be done within 30 minutes.
30 minutes
Within 30 minutes.
or 500 hours.
Yeah.
동안 할 수 있다고? 오케이. 시간이 있다.
And when you're doing service, you're usually 2 guys, I guess, working. So 15 minutes each
15 minutes enough.
per person, 2 guys. Yeah. And the customer can't say it does no because it's in the manual
Manual.
and they have to read the manual. And it's also on the lubrication chart on the machine. So when you open the cover for the hydraulic tank,
Mm.
it tells you 500 every 500 hours and all the points.
Yep.
So, and also you guys have to train them.
Praying them.
Yeah. When they buy the machine, you have to train them that this is part of the maintenance. Unless we're going to end up in discussions afterwards when the axles failed. Yeah. And a lot of pain for the customer.
I guess this is the shaft is the failure point.
Yeah.
Yeah.
Yeah. But
At least a lot of the customer here.
yeah, and a lot of the failures that we've seen on the shaft is no lubrication.
No.
Yeah.
Next time we discuss about chemical.
Yeah. Yeah. We have our tandems. I was going to demonstrate it, but it's very muddy out there, so I don't think we're going to do it. I was planning to kind of reverse into the ditch here to show you, but it's too muddy today.
No.
So we have the 2 tandems. So they are independent movement of them. So they have 25 degrees movement up in the back and 15 down. So that gives us the machine a great ability to climb uneven terrain. And also when doing stockpiling, it's a good feature because you can back up onto the previous pile you have. So you can do a very easy stockpiling of stuff with the machine. Yep. And they have the turning rings, as I mentioned. It's basically the same turning ring on the tandems. That's on the front, same part number.
아, 여기.
Yeah, the bearing.
The bearing.
Yeah, same bearing for articulation. Yeah. Yeah, we have the parking brake on the rear axle. So this is hydraulically operated. It has a fail-safe, so if you lose hydraulic pressure, it will come on. Also, when you turn ignition on, it will automatically come on. We mentioned a little bit about that internal differential, that diff lock button we have in the cabin. So we'll have a look at how that works here in the next slide. So our truck is always 6x6 constantly. So during normal driving, you have equal power distribution to each wheel. So That means you have 1/6 of the power to each wheel, 2/3 of the torque going to the back, 1/3 to the front. Then we have this diff lock button in the cabin. And what we actually do is this is basically like an open differential, like a normal car differential when in normal mode. So meaning if your rear wheels get onto slippery ground, all the torque is just going to go this way because torque travels the easiest way. Same as your car differential. If you have your car tires, one side on slippery, one side on solid, it's just going to be spinning out on the slippery side. So when you activate that diff lock button, we lock together the front and the rear axle internally, and we change the power output. So now we have 50% of the power to the rear, so we reduce the power to the rear a little bit, and we have 50% of the power to the front axle. So that meaning in slippery conditions, you have the same wheel speed on the front and the rear axle to avoid wheel speed and avoid differential wheel speed and improve traction by having the same turning speeds at the front and the rear axle. It also saves the internal differential, because if you're spinning on the rear wheels while the front wheels are stationary, you'll be damaging the internal differential. So it's to avoid damage and give you better traction. The differential, this is manually on, but it has a function. So when you turn it on one time, and it kind of stays on all the time. It has a function, so it will disengage when your speed goes over 20 kilometers. It will turn off, because then you basically don't need to have it on. And when the speed goes down below 18 kilometers, it turns back on again. It's kind of a one-time for a driver. You just push it, and it kind of stays on all the time when you need it. And it's very recommended to use it if you're in slippery conditions, like you have on the outside here. Yep.
오는데 SLP는 기본적으로 해제를 하는 것 같이 저도 그래서 이 사고로 현재 내일 리그거든 저희 스페인 가는데 지금 미끄러웠어요. 20km 만약에 넘어가면 좀 부담이 있고 하고 할수 있어요. 그래서 뭐 시키는
노다 알고
So yeah, the front tubs. So they basically have a planetary section at the end. They have a brake section in the middle, and your axle connection at the end here. So no special design really. Sorry?
Yes.
Was it a question?
No.
I thought I interrupted you maybe. So yeah. So yeah, it's basically a planetary similar to we use in the wheel loaders.
Yeah.
It's just that we use a different brand. Yeah. As I mentioned, as a part of that maintenance, when you're doing the lubrication on the machine, you have that tunnel going where the shaft goes through. When you're doing the lubrication, kind of try to clean that tunnel out a little bit. Because if you have buildup of dirt, that can push against the flanger. And over time, it can go past the flange, through the seals and into the bearing. Especially if you're driving in deep, muddy, kind of really, really bad conditions, because what will usually happen is that between the wheels, when the wheels sink in, you get this ridge of dirt, And drivers usually start to do that Volvo method then. And what you do is kind of you push those tunnels into that dirt. And over time, you can get a large buildup of dirt, and that kind of pushes into the seals of the planetary. Yeah. So, yeah. Yeah, face seals towards the planetary. Lip seals against the shaft. Then you have your discs. You have a piston. You have access plug on the hub for checking brake wear. So you can measure with the depth caliper. Then it's basically comparing it, the set distance. So this is kind of a distance that's measured when the hub is new. So they measure the distance from, let's see, it's this one, and they measure the distance down to the piston. So you actuate the brake, and you measure the distance from the ridge here down to the piston. And this is what you see at the factory. This is made by Kessler, so I kind of stamp in that initial clearance. Then you can use it to compare when you do your checking of the brakes.
저걸 해가지고 이거 직전한 제고
레이저를 낸게 시스템을 그리고
아 그러네.
근데 이니셜 이 미리
매장부터
2mm만
So there's a couple of different places on the hub where you can access this. And for the DF30, you can have 2 millimeters of wear, and the DF45, 3 millimeters. That means that if you get to 3 millimeters, it means that your brake lining is about to disappear. It's almost worn out.
근데 그때 같이 봤을 때는 이거 봐야지 대기시 이거 가면 돼 위에 충분한 상태에서 밀린다 보는데 그걸 빠져 이거 일부 들어갈 살고 이렇게
So you measure from the countersink on the plug. So it's from the countersink. It's not from the yeah, it's from the surface that the plug is resting against. It's not from here, but from the sealing surface.
기준면에 카운터 싱크 쪽에 안쪽을 잡아야 되니까 기준면 전략 측정하라는.
So it's not from the hub outside, but it's from the machine surface.
카운터 싱크부터 잘 잡고
기준면
여기 안에 있게요. 거기부터 잡으라고. 귀가 튀었네.
We also have a drain plug. When you're doing brake services, there's a drain plug to drain the oil inside the brake section. And you have your drain plugs for the planetary section. That's on the outside. This is on the inside of the wheel, the other one. You normally don't need to use this for normal service, but if you're rebuilding them, there's kind of 3 adjustment screws to align the piston back again. So, but that's different. That's for rework of the hub, but just what those plugs are for. It kind of sets when the piston's in neutral position or off position, it's kind of resting against 3 plugs to kind of have it level against the discs when you activate it.
But the brake air gap.
Yeah.
That plug? Yeah.
Yeah, so you can also set the air gap
Yeah.
between the piston and the brake discs.
It's used when we
Yeah, usually when you're reworking,
build-
basically. Yeah.
yeah we build.
Or in case that one of the screws fall out, that can happen. But that's a different part of the shop manual, so I'm not going to go too in detail. But that's what these plugs are for, is just to align
Okay.
the piston, also adjust the air gap,
Yeah.
the clearance towards the brake discs. We have a couple of hoses going to the front hub. So we have the hydraulic supply from the brake system. We have the cooling. So all the brakes have a cooling. So they're connected to the tank there, which we saw was connected to the pump and engine, which is connected to a small cooler in the middle of the cooling pack, which kind of just constantly circulates the oil through the hub. And we also have a breather hose on the front hubs. So it actually breathes, it sits here and kind of breathes the planetary section to avoid overpressure. Yeah. Rear hubs is basically the same. It's just a different flange connection. So that's this will be the front one with the brakes on. So, but instead of that axle connection, you have a stub shaft going into a gear inside the tandem. Same setup, minus the air breather. It doesn't have it because it breathes through the tandem and to the differential assembly. So you have a breather on the differential. Because the planetary, the tandem, and the differential, they all share the same oil. So it's open in between them.
It's for
쿨러를 앞에마다 있어요?
most of
쿨러를
that.
쿨러를 앞에마다 있어요?
Yeah, so what no, the cooler is only for the disc brake.
This brake.
Yeah.
On here.
Yeah, only on the front axle. Yeah.
쿨러는 뒤에 없대요. 쿨러 뒤에 없대요.
No, because we don't have brakes on the rear axle.
이어서 브레이크가 없고.
Yeah. So this hub has brake on it. This one have a brake on it.
Yeah.
This one doesn't have a brake hub. So this is just planetary. Yeah. So the brakes on this one is also connected to the cooler. Yeah.
330 has a front cooling kit and front and rear cooling kit, right?
That's
Stage one.
Stage one's different. We're not going to mix that into this. But
So I wanna make
yeah. That's totally that's a different.
What is the meaning of 3x?
It's just that you have also the air gap adjustments, 3 of them. Yeah. So there's one that you don't see on underneath there. Yeah. So basically looks the same as the front one on the cross section, minus this part. So no big difference. And yeah, that's for the rear axle. So it's basically just a planetary, no brake disc. But you will have brakes on this one, and you have gears connecting. So when you put brake force on this wheel, it will also be transferred
텐덤이 어차피 이어져 있잖아요.
네.
기어를 들이면 되니까.
네.
그 앞에 잡아주더라도 얘를 감이 세개 주는 것 같아요. 세개 주는 거 같이 연결되어 있기 때문에 만약 이렇게 생겼으면 왜 이거 이렇게 생겼으면 따로따로 다 둬야 되고.
Yeah, oil level position, drain for the planetary, tandem. So here you see that this one has brakes, this one hasn't. Then behind each one of this, there's a gear. Yeah. Yeah, as I mentioned, we have the same shared oil supply between all the components. And we have internal baffle plates. So if you drive the machine on a sideways angle, we have baffles to keep all the oil from just running into one side. So that basically splits when you're doing, let's say, oil service and you want to drain, it's split into the hubs, the tandems, and the differential. So when doing draining, you have to drain the differential, you have to drain the tandem, and you have to drain the hub reservoir. So we can have a look at that here just quickly now, so everybody can see.
예, 빼래.
So if I do filling, if I fill at this point or I fill at this point, it will eventually blow out everything. But inside here, there's a couple of baffle plates installed, and they have overflow holes, meaning that the level won't drop below a certain level. That's kind of halfway here. And I want to do draining. I have to do the drain plug on the tandem. Sorry, on the differential. I have to do the one on the tandem, which sits on the outside here. And if I want to drain what's inside between the tandem and the planetary, I have to pull this bolt out. This bolt goes into a hole in this plate, which then drains the oil that sits in here into the tandem. And you have to do that for all four wheels. So there's a lot of points to open, but that's kind of the way the design is. That's important to keep in mind.
Once again, when we drain oil,
Yeah.
starting point from differential.
Yeah.
Yeah, and then tandem.
Yeah.
And then finally this one.
Final wheel hubs, yeah.
Okay.
Yeah. So if you just unscrew it a little bit, it will probably drain from here into there and just run down to this drain plug, which is the lowest point. Yeah. So this is not a drain plug for this section, but it's kind of it's a long bolt that goes through this plate. So I unscrew it, I open a passage between there. And also when you do refilling of the hubs, it could be a good idea just to check the level of the planetary. It's an open design, but if you're filling the oil in cold condition, there can be some delay for the oil to get all the way to the planetary because of a very small passage between this part and into the planetary itself. So if you're using high viscous oil in cold temperatures, check that the oil has gotten all the way through before you start driving. That's a tip. We have tried it.
그러니까 시간 걸린다. What you have to do is just wait
Yeah,
to
just wait.
equivalent oil
Yeah.
level.
Yeah.
How long does it take?
Uh,
It's filling.
Worst case, maybe an hour or something.
Oh,
It's not too long, but it's kind of, there's some delay there. And this is from our experience that we've been too quick. We replaced the hub, refilled the oil, and just started driving. But the oil didn't have time to flow into the hub before we started driving.
기다려야 될 때.
한 시간.
추울 때 많이 기다려야 될 수도 있대요.
우울증 사장이 까마지네.
So even if you check the level here, when you're doing refilling, you check the level, it doesn't always mean that it's kind of the same level at the hub.
Yeah.
Because if the oil is thick, it takes a lot of time for the oil to kind of flow into the hub. So,
위에서 레벨이 맞는 것 같이 보여도 여기는 하는 게 좀 시간이 걸릴 수 있대.
다시 그냥 안전하게.
먹고 와.
저
풀 때는 못 하건데. 알풀 때는 나도 운전을 해야 돼. 여기 올리고 여기 올리고.
앞서리는 그렇게 설명. 근데 좀 더 빨리 하고 싶으면 거기다 몇 명이서 붙어가지고 빨리빨리 넣고. 그래도 기다려야 돼.
어차피 넘어가는 폭이 되게 작고 나가서 거의 얘가 정확히
yeah,
Very nice. Oh, very nice.
that's good to see.
Yeah, it's fine. Hey, it's fine. Why wait for one time? It's fine.
Yeah. It's nothing gonna happen, especially if it's cold outside and using thick oil. It's very
We
narrow.
will advise if the cold weather, please don't replace.
Yeah. Stay inside, stay at home.
It's at home.
기다려.
It seems a little bit similar to the loader, fill loader, right?
The hubs?
The hub.
Yeah, I guess it's
Power and
similar.
axis are same.
Um,
But just different is the
yeah.
tandem line. So due to this articulated luggage that applies to the tandem systems, and that's what we wait for a long time for
Yeah.
during the oil.
Yeah.
That's probably
So it can take some time because they have a large oil quantity that has to be drained. But the good thing is we kind of extended the service intervals a bit. So now it's every 2,000 hours.
2000.
Yeah. You kind of do that initial service and then it's every 2,000 hours. So it's luckily you don't have to do it too often, but around once a year for normal applications. Maybe 2 for the extreme ones. You see at the bottom there, that's actually the drain plug for the brake reservoir. Yeah.
Not this one.
No, that's the checking the brake clearance.
Clearance point.
Yeah. So, and here you have your for the cooling. Yeah. To have cold supply, hot return, and this kind of splits between the 2 different hubs. So cold oil, hot return oil, going back to the tank again. And we have a temperature sensor, so we can monitor what the temperature in the hubs are. And we have the same distribution block for the front axle Yeah, so that sits on the back of the transmission.
Uh-huh.
That also has a separate temperature sensor.
Mm,
So we can see if we have front brakes or rear brakes overheating.
yeah.
A sensor for each of the brakes, front and rear.
Yeah, so one for each axle.
또 측정할 때 이제 프론트랑 리어
네.
이거 측정기가 있다고
네.
하시죠.
센서 달려.
Then we have a sensor inside here. That's for the axle oil.
That's a lot. Sorry.
Axle oil,
Ah,
tandem oil. So it's behind the bracket there.
Temperature sensor.
Temperature sensor.
hydrogen oil.
네, 그리고 온도
저 팬덤 올 드레인 폴트.
Can you tell me where is the rain port from the tender
Tandem,
here?
yeah.
Okay.
So same on both ends for each hub.
Yes.
저는
네.
이거 혹시 아웃사이더
Is there one outside? On
Yeah.
the outside as well?
On the outside?
On the middle, right?
Yeah, that's
middle.
for the tandem itself. So
여기 사이에 보면 있고요. 하나, 둘, 셋.
여기 디퍼런셜 해가지고 4개.
Yeah. Yeah.
4개.
So ideally it would be here, but it's a bit too exposed. So that's why I have to put it on the side. It's a kind of more protected
Yeah.
position.
Okay.
때문에 여기 안쪽 안 빼도 돼.
맞아요. 안 띄어서 빼도 갑자기 안쪽이 쉬울 것 같아.
근데 아무튼 밖에서 빼면 양쪽이 앞으로 준다는 거예요.
If we,
내가 있다고 그랬어.
if we unplug this,
Yeah.
we don't have to use these.
Yeah, you have.
Oh,
You have.
Yeah.
Because this plug will only drain the tandem.
Okay.
Then you have to open this one
Drain
to
the
drain the planetary.
플레이테레만 이제 이게
그러면 위를 다 하려면 하나, 둘, 셋, 넷, 넷, 세븐 디퍼런셜.
아,
토탈
total 7 drain. Wow.
어.
Wow.
Because this you have this plate here,
Yeah.
and it has a hole in about this height, kind of an overflow. So when you fill oil into this one, it'll kind of spill over and go into the planetary.
So you
But-
have to fill it up through here so that it goes into the.
Yeah, so it's the same thing between all of them. So it's kind of a overflow hole. So the oil will flow into it, but when you drain this one, it will retain the oil inside here. So that's why you have to pull this plug, because this is basically a bolt going into this plate. So when I unscrew this bolt, I open a hole between this side and this side.
네, 이게 그 드레인 하는데 그 장소가 총 7개인데라고 하셨어요.
네.
그리고 하나. 그리고 이거는 여기 그 플래닛테리 드레인하는 거고 여기 그 반대편에
Master, when I fill up the oil,
Yeah.
네,
the
이거는
plug
팬덤을 드레인하는
fill up the
이거를 드레인하기 위해서
Okay.
Yeah, then it kind of fills into everything. Yeah. But for draining, this kind of for the sideways, so it doesn't run to all to one side. So there's an overflow port in this place. There's an overflow port. So when you fill into this will fill up and then start flowing into the planetary. Yeah. So same thing between this one and the differential as well. So there's an overflow hole, so you fill it up, and then it starts to spill into this.
Then normally, if I check all the quantity of the volume oil, then
Yeah.
then I think that someone something can I say very safe something.
Yeah, yeah.
Yeah.
So when we inspect, you just pull the inspection plug on this one, okay? And then you check the inspection plug on this one. So then we know that everything is filled up.
Yeah.
Is there any way to speed up the process? Any tips? The filling up, you know, like
Two guys filling, one from each side.
from the side. Other than that, just
Yeah.
after that, you still have to wait and
Yeah.
check. All right.
So there's basically no really quick tip.
All right.
이어지긴 하는데 양쪽 보여야지 팬덤이랑 엑셀이랑
So what you can do is kind of drive the machine up on some blocks. Then you don't have to drain on outside, but you just pull the
One side.
end plugs. But you still have to drain, kind of pull all four of them.
What do you mean by that?
Yeah, so if I place this wheel now a bit higher, I kind of tip the tandem a little bit. So if I pull this plug completely out, it will drain both the tandem and the bearing or the planetary at the same time. It's a bit easier than trying to get a bucket in between here, maybe.
This also not only drains the planetary, but also the tandem. This
Yeah, it will do. Yeah,
oh,
yeah, because this is basically goes through the tandem into the planetary.
okay.
So if you're doing a kind of, instead of having to open
Like 3 buckets or
7 plugs, you can open 1, 2, 3, 4, 5.
It's leading to the down
Yeah.
here.
So if I drive the machine in, so the tandem is a bit higher in the front, just a little bit. So you can see the angle of the tandem. So if I lift the tandem, so it is kind of slightly tilted down. Then I just pull this one, and I drain this planetary and the tandem. And when the tandem is empty, I pull the other one, and the oil from the planetary there will spill into the tandem and out of the front hole. So that kind of speeds up the draining a little bit, maybe. No. Oh.
Might see better on the flat face when filling up the oil.
Yeah. Yeah, so when you're filling again, you have to be level. Yeah. But if your level is exactly or just below, not a big deal, but then you can fill it up, and when you take the machine off the blocks, just put that last few liters in just to get it the correct level. So if you join me back here again, on this side.
보이겠습니다.
Thank you. So that bolt in the front there, it goes from here into there. So you open a passage between here into into the tandem. Yeah. So we have your drain plugs there, and you have level plugs on the differential and level plugs on the tandem. Yeah, VC monitors the temperature of the oil, both for the tandem oil and also the brake oil. And the temperature sensors on the brake cooling, if you disconnect it, you have that fan failsafe, then the fan will default to full speed. Just make sure that you have enough cooling for the brakes. Yeah, differential, limited slip differential, nothing special. This is basically how the tandem looks inside. So you have a shaft from the differential, you have a pinion gear, then you have transfer gears to the planetaries.
Size of the gears.
Yeah, so this is a bit smaller, but this is kind of same size. So it's a one-to-one ratio through the tandem. Yeah. So there's a ratio difference, let's say, in differential and in the planetary. But the tandem is one-to-one. So if you see here in the tandem, you'll see that's the cover. This holds the pinion gear. So if you want to remove the differential, you have to pull this one out to get the axle out of the differential. Then you have
But the other gears are fixed on the same position.
they're fixed in the same position, but it's only for if you want to take the differential to remove it. Because you have those the shafts going from the pinion gear into the differential. So you have to unbolt this one and to pull it out to pull the axle from the differential. Yeah. The rest of the gears, they are secured by the bolts here. So there's one bolt here. There's one on the outside going in. So if you want to replace the internal gears, you kind of have to pull the covers out and kind of place them in one by one. So you get access to get them in and out through the other covers there. So this is basically a straight through bolt, and there's two ball bearings, and it holds the gear in the middle. And it's a very good design, but we haven't had any failures yet. So we've been using this design now since 2017, and we don't have any tandem failures yet. It's been a very, very good design so far, strong design so far. Yep. As I mentioned, we have the brake cooling. So we have the pump mounted on the engine. So it draws oil from that brake cooling tank we have in the back here. It draws it through from the tank to the pump to the cooler. And it goes from the cooler to that first distribution block, which is the one on the back here. This one splits it to the front axle and also to the rear axle, where you have that second block, which then splits the cool oil to the two brake sections. And also you have the return, which then is gathered to the single return line, to the filter and to tank. It's a very low pressure system. It's basically just flow. So we should have around 1 to 2 bar measured behind the filter. Yeah, as I mentioned, we have a temperature sensor for each block, monitored by VCU, so it uses it to control the cooling fan. Yeah, and fail-safe, so if it's disconnected, the fan will go to full speed. Yeah, my filter also has a bypass, so in case the filter gets blocked, because brake oil is usually very dirty, so you can risk blocking it sometimes. We have a bypass just to make sure to keep the cooling going. There's no monitoring of the bypass on this one. Yeah. Yeah, this we kind of covered earlier a couple of times, but basically our suspension system, as we see. We have our sensors, cylinders, accumulators connected to the hydraulics, but this we already covered, I think, very well. The suspension in this truck is a bit unique because we have semi-independent suspension. So one wheel can move without directly affecting the other one. Because we have the two separate axle arms, and we have a tube in between them, but that's on bearings, which allows the arms to move independently. So you have kind of a semi-independent suspension on them. Yeah. I think this is already covered. Yeah, already covered. Articulation bearing. So this is one of the also the unique things about these machines, that we use the articulation bearings. So it's basically a three-piece bearing. You have an inner ring, then you have an outer ring and a cowl bearing. Then you bolt the outer ring to one component and inner ring to other component, and it kind of moves inside each other. So this allows us to have this very compact design. But again, we're very depending on that you have the correct lubrication for the bearing and that it's constantly lubricated. Yeah, same bearing on the front, same bearing on the tandems. The bearing, the inner ring, is kind of grooved, so it has a pattern to carry grease around the bearing. So it has a crisscross pattern, just to make sure that all the parts of the bearing get grease. because during normal driving or all the load is kind of concentrated on one small point on the bearing. So that's why we kind of are depending on having grease there at all times. Because there's a small area, maybe this long, carrying the most of the weight or the bulk of the weight. So this just compare it to the old design we had with the new design. So for the older DA40s, same kind of bearing, but we had bronze inlays against the contact surfaces. The new bearing is a hardened steel bearing, all steel. So it's a much more durable design than this one. This was not a bad design. This is improved design. So we have a larger bearing surface, and a hardened surface, and we have better grease pattern for it. So if you maintain it correctly, this will have a very long lifetime. If you do not maintain it, let's say if you don't grease it, it will probably fail within 2,000 to 3,000 hours. If you use poor grease and you don't check up on that the greasing is working, it will fail at around 2,000 hours. Easy. If you keep it maintained, it will last more than 10,000 hours.
10,000 hours.
More.
More.
Yeah. The average lifetime we got of the old bearings, if you maintain them, was between 8,000 to 10,000 hours in most conditions. Some conditions more, but kind of in general, between 8 to 10. This is improved, so if you maintain it correctly, it should last even longer. So, and we still haven't had one failure on the new bearings. But as soon as you start to use cheap, low-grade grease, you don't fix the problems on the lubrication system, this is going to be your biggest headache on the machine. And it's very connected to that pump here. If you don't keep this one working, that one will stop working.
Every morning we will check the
Yeah.
greasing.
Yeah. So it should be a part of the daily checklist.
Really check.
It is part, you will do a walk around with the machine, you check that it's functioning. And if you get greasing failures, it's very important that they get the technician to fix it. So, yes. Yep.
Compared to previous
Yeah.
model.
Yeah. So it's changed.
It is only worked by hydraulic.
Yeah. So the old DA40, that was kind of a single cylinder with oil and gas inside. Yeah.
Front and tandem.
No, only front. Yeah, only front that has suspension. On this new one, the cylinder itself is completely oil, all oil, and you have the accumulator next to it with the gas. So as the suspension is moving, the oil in the suspension is kind of goes into the accumulator, and that gas pressure kind of decides the ride quality. Yeah, only oil. Yeah. Yeah. So basically, on this suspension, you hit the bump, the oil will go into the accumulator, then the accumulator will push that oil back again. So the actual shock absorber is the accumulator.
X대는 우리가 이제 입체적인 잘 이렇게 논란을 잡으면 어차피 얘가 역풍론에 있어서 문제가 이게 근데 하나 얘가 완전 다른 다른 같은 거 전혀 다른 근데 포스가 연결돼 있어. 포스가 여기 컴퓨터레이트랑 연결돼 있어.
그래서 큐에서 압력을 밀어주는 하나씩 생성돼 있는데 가스는 이제 큐에 가스랑 이제 그 유압 가스 들어가 있는데 어제 좀 올라온 거 보니까 이제 어제 가스는 위에서 충전을 해서 돼 있었어요. 근데 이제 옛날에는 여기에 큐에도 그뭐 오일을 넣어야 되는데 이제는 그 오일이 자동으로 주입되게 밑에 들어온다고 했잖아요. 어제 그래서 지금 그 얘기하는 거예요. 가스랑 큐에 가스랑 이제 오일 들어가 있고 여기에서 불이 들어가 있고 여기서 여기는
아니 SM은 지금도 못사니까.
11 hours.
30 minutes left. Yeah, I think we're close to finishing. So.
You don't go to the soul.
Yeah. No, we're good. We're getting close to finishing here now, so we'll be done by 11:30.
Target time.
Yeah, maybe a bit before. There's just a couple of slides left there, so. Yeah. So back to the tandem bearing. So we want to keep this part greased very well at all times. We also have some seals inside the tandem bearing. So you have seals here to keep the oil from entering the bearing from the tandem. Then you have seals on this side, so here both of them are pointing towards the tandem. Here we have one pointing in each direction, so this wants to keep the grease inside the bearing. This wants to keep the outside from going into the bearing. But you'll have grease coming out because it's pressurized, but it tries to retain as much grease as possible. What will happen if you start to get wear on the bearing? You'll start to compress the seals. You also get wear on the seals, and you have oil start leaking through. Yeah, and when there's oil coming in, that will wash the grease out and just accelerate that failure process. So on the old bearings, they were recoverable to a certain degree because we had bronze inlays. But usually when people discovered that they were worn, they were too late, so they'd start to eat into the screws holding the bronze rings. These ones are kind of not recoverable if you have a period without grease, then the damage is already there. So you want to maintain them as good as possible.
윌이 조기 이렇게 퍼져서 이렇게 나오죠. 오일하고 만나는 데가 조기여서 여기여서 이렇게 빠져나오면 이제 얘가 나간 거다. 그리스하고 오일하고 섞일 수 있는 데가 저 포인트다라고 얘기했어.
Yeah, just a tandem, I think. Another thing, if the bearing starts to get worn, for the articulation, not so big problem. It's just driver comfort will be affected. If the tandem rings start to get worn, the problem is that we want to keep the axle going from the tandem to the differential perpendicular. If the bearings start to get worn, the tandem will start to get a misalignment. Yeah, and that will put stress on the differential and also on the pinion gear inside the tandem. So if you leave this for too long, you can cause a lot of damage if you don't. Yeah, So there's a procedure to check the wear on the bearings. It's in the shop manual. We allow for 1.5 millimeters of wear on the bearings. It doesn't sound like much, but when you see it, it actually adds up to a lot of play in the bearing. Yeah, you see, it's actually a lot of play in the bearing. So just going to show you quickly. It's also described in the manual, but if you want to check articulation bearing, you place a big jack underneath there. Yeah. Then you place a dial gauge from here down to the top of this bearing, and you just put pressure on the center, about 8-10 tons maybe. You don't have no lifting, but just pressurizing. Then you'll see the flex in the machine. That's not so critical. That's mostly comfort. But for the rear, it's a bit critical. So if you want to inspect the rear tandem bearings, it's a similar procedure. You place a jack underneath. Then you have a dial gauge. First, you can check a dial gauge from here to there. And as you're lifting the differential, you can see the sideways wear. Yeah. So if you lift this one, if there's any wear, it'll creep in like this. That's the sideways. Then you do the same thing with the stand to the outer ring, the dial gauge to the outer ring. You lift it, and you can see the play between the two parts. Because this one is connected to the inner ring, this is the outer ring. So you can see the play between the two parts. And if the wear is 1.5 millimeters,
25.
yeah, you need to renew the bearing.
다이얼 게이지를 해가지고 얘네들 릭을 해줘야 돼. 릭을 해줘가지고 이너링하고 아우터링을 보는 건데 아우터링을 하면 아우터링하고 이너링 플레이를 볼 수 있고 그 다음에 저기에서 디퍼런셜에서 이너링을 하면 이 디퍼런셜하고 이 텐덤하고의 이거 플레이를 볼 수 있다. 근데 그게 1.5 넘어가면 바꿔야 된다. 바꿔야 되는데 가면 갈수록 이제 걔는 맞지.
And if you lift it and oil starts pouring out, no point in measuring. Then it's already too far gone. If you're lucky, only themes, but most likely you definitely need a new bearing.
Probably depends on the situation, how long the machine is operating, but
yeah,
normally, how long do you expect to this happen to replace the ring?
We don't have any statistical data yet, but we're kind of expecting at least 15,000 hours. Yeah. The old ones, they used to fail between or need rework at 8-10,000 hours, depending like in heavy applications. We had bearings that are 12-15 and still okay, but that's kind of they're not that extreme heavy application. But for heavy duty, between 8-10. So let's say you do a bearing check at 6,000 hours, just to get a rough idea of how it's going. So for the old bearings, I used to recommend that 6,000 hours you kind of check them, because then you would start to get close to the failure point in certain applications, especially Southeast Asia. Yeah, like Indonesia. So,
They are operating for 24 hours.
yeah, 24 hours, heavy loads.
Yeah.
Grease is kind of
That's why the lubrication is so important.
Yeah.
근데 그 두바이 쪽으로 가면은 사실
아무 할 수가 할게 없는데.
말수도 검사하면 보이지.
So that's it for my part. So far. I think I've covered most of the important stuff, so I think I'm done. Yeah.
Thank you.
Thank you.
Appreciate that.
You've been very good. You've been very good students.
Very good training.
사진들 좀 찍고
타율을 집어넣어야 되는데 맨션하고 많이 이런 게 먼저 집어넣어 정확하게 시문이 뭐 다음 주에 한번 더
먼저 올려보내고 나머지 여기 정리하면 되니까 그게가 나을 것 같아. 집에 할 거니까. 사진을 찍고
팬덤이라고 생각을 해.
We take a picture together. Okay?
Yeah.
Take a picture together based on the one. Maybe.
Yeah, we can do that.
차를 여기다 뒤로 빼놓으시고.
저희 사진 빼겠습니다. 사진 주세요.